All right, hey, if we're going to do this, we got to focus up real quick. Homework in your playing book, 8-5. Our lesson's going to be just review of the chapter. It's our problem-solving lesson. We will talk about when we want to take your mastery, probably at the end of class if there's time. But I wanted to take a second to talk about Powerball because a lot of people are talking about it. Your parents are maybe buying tickets. So here's how Powerball works. You have to start with 5 numbers, and then there's a number called the Powerball. These 5 numbers all range between 1 and 69. So all of these will get drawn and be numbers between 1 and 69. The last number ranges from 1 to 25. So here's like the little description. According to Wikipedia, nationwide there's more than $1 billion, because this is current. This was like as of yesterday. So this is how they can award the money. The money they award is based off how many people buy tickets. But if no one wins, it rolls and goes to the next drawing. It only gets drawn every Wednesday and Saturday. So this past Saturday, the prize amount was over $800 million. Nobody won. Out of all the thousands and thousands and thousands of people that bought tickets, and think about every person normally buys more than one ticket, nobody won. So I've got a little news clip about the probability of winning, and then we're going to look at some other probabilities because we're going to get to probability here later in the year. So it's good because this is current right now to talk about it, just so you understand how this applies.
Into a record $900 million. And in the 44 states that participate in the drawing, ticket sales just ended about 2 minutes ago. Millions of Americans now hold tickets in their hands, waiting for the big Powerball drawing to take place in about an hour. News 4's Allie Ingersoll is live in the newsroom to tell us what your odds of winning are. Allie?
Callan, well, unfortunately, the odds, they aren't.
Anyone know? I think some of you guys do. I had it on my chalkboard earlier.
62 million, right?
Even worse odds than that. You have even less chance.
1 in 29.
Close.
1 in 29 million.
That good. It's around 292 million, actually. But that's not stopping people from buying tickets. People all across America, including right here in Western New York, are hoping they'll be tonight's lucky lottery winner.
I just want to get a couple quick picks or something for the Powerball.
I've never bought a ticket before. I just really hope I win.
Alyssa Reichert is among the many with those hopes.
But what if you do win? How excited will you be?
I wouldn't be going to work on Monday. I could guarantee that.
Yeah, it'd be nice to win something.
The 900 million.
Of all the lottery tickets that you could buy, of any of the lottery tickets in the machines at the store, of Rolling Cash 5 or whatever, this is literally the least chance that you have at winning. It is the hardest lottery to win, but that's also why it's the biggest. So you heard what they said, every ticket, 1 out of 292 million. So that, compared to other probabilities, here are some risks that you take every day. Your probability of dying as a pedestrian involved in a crash, like transportation, so you're walking down the street, get hit by a car, your chances of getting hit by a car are 1 out of approximately 50,000. Your risk of, let's look at some of these. Your risk of dying from a fall off a ladder or scaffolding, like when you climb ladders, 1 out of 700,000. A little more likely, so the second number, the smaller that second number is, the more likely it is. So falling down stairs, oh no, you climb stairs probably every day, 1 out of 180,000. These are all 100,000s, right? We are talking with the Powerball, 100 millions. Your risk of drowning in the bathtub is 1 out of 800,000. You are more likely to drown. Hey guys, this is where it gets funny. This is where probability gets really funny. You are more likely to get hit by a car, struck by lightning, and drown in your bathtub all in the same day than you are of winning the Powerball jackpot. Yes, you can do the math. So I've got, I don't know how this is going to upload since it converts to a PDF, but this will be in the video if you want to see it. I mean, I'm going to scroll down through all of these. Risk of dying next year, smoke, fire, and flames. So all causes, so your risk of like dying in a fire is 1 out of 92,000. Ignition of night, where your risk of your pajamas lighting on fire.
I saw that.
1 out of 22 million. You are more likely for your pajamas to light on fire and kill you than you are to win the Powerball jackpot. So when people are saying, oh, I'm going to buy tickets, I'm going to buy 10 tickets, that's going to increase my odds a lot. Okay, sure. So now you're 10 out of 292 million. Then you're a million out of 292 million. So then your chances would actually be 1 out of 292 if we simplify the top and bottom. But you would have spent $2 million buying tickets, and you still only have 1/3 of a percent chance. Because if we look at the math, I'm going to scroll down through the rest of this so you can see them. Forces of nature, your risk of dying in a flood is 1 out of 31 million. Your risk of dying in an earthquake, 1 out of 9 million. I mean, look at these. All these probabilities are more likely than the Powerball jackpot, and they're ridiculous. Your risk of poisoning yourself is 1 in 52,000.
That's suicide.
Likelihood, unintentional injuries, death at work. So agricultural farming is dangerous. So like this is pretty dangerous. Risk in mining is really dangerous. Your risk of dying while mining is 1 in about 3,500. That's pretty dangerous.
Can you go back up to the medical?
We gotta move on with class. This will be in the video, so you can look at any of these in the video today. So I did the math. Here's your odds: 1 out of 292 million. So we do that division, and when I convert that to a percent, that's 0.0000003%. That's 3 millionth of 1%. So take 1%, chop it into a million pieces, and you get 3 of them. That's your chances of winning the Powerball jackpot. So, Eminal, even if your parents are going to buy you a Powerball ticket, it's not very likely that you're going to become a billionaire. So Bella's asking, so wait, 292 million tickets were sold. That's not what that means. That means there are possible 292 million combinations of numbers. So when they draw the numbers, there are 292 million possible outcomes. And when you buy 1 ticket, you are 1 of those outcomes. When you buy 2 tickets, you're 2 of those outcomes. Now the problem is if you win it and somebody else wins it, you got to split the money. Or if you win it and 5 other people, yeah, that's still not that bad. But your odds are very, very small. So just remember that when gambling, math is extremely important. I will not be wasting my money on any Powerball tickets.
Thank you.
Crystal?
So me and my dad and my brother were talking about this over the weekend.
Yeah?
And my brother's like, what if Bill Gates bought a ticket and won? And my dad's like, well, that'll be just like $5 for him.
Well, Mr. Kabila and I were talking about that, and we were saying how much money you would need to like increase your certain probability. Like, what if I wanted to buy 1 of every possible ticket? Well, that wouldn't make any sense because then you would have paid for the Powerball essentially. But if you wanted to buy like half the tickets or there are certain things, but you'd have to spend all that money up front, and then you still aren't guaranteed to win unless you literally bought every single ticket, and then you probably have to split it because if somebody else had it. All right, let's check
Welcome to Equation Chef. Your challenge is to use words to describe or a picture to model a real-world situation that relates to the equation shown. Your situation must somehow involve the secret ingredient, bagels. Reveal the equation. Go.
So our equation here, and you don't have this on your notes, we're just trying to warm up our brains or remember what we were doing last week. We have 6b plus 1.50 equals 5.4. Who could turn that into words? If this is like last week when we were involving bagels, but this purchase is not just bagels. I'll take it that far. So think about if you go to Tim Hortons or Starbucks or any of those places and you're buying bagels, what else might you be buying? how would this turn into a verbal equation? We're now taking the numbers and working backwards, turning it back into verbal. Bella?
Maybe you could buy like a coffee or something.
Yeah, maybe you buy a coffee. So this, what would 6B represent? The price of 6 bagels, right? So it's the price of 6 bagels. But I don't know how much each bagel costs because that's my variable. My 150 here, that might be like a coffee or something that I only buy one of. And what would this 5.40 be? Luke?
The total of the 6 bagels and coffee.
Yeah, the total that you spent on everything. So you want to be able to look at these situations and remember, last week we did a lot of taking words and putting it into an equation, but be able to take an equation and flip it the other way, represent it with a verbal situation. Because I might, on your mastery, give you an equation and say, write a story to go with this, and then solve. Or I might just have you write a story and an equation, so you might make it up on your own. So you might start thinking now, if you were asked to write an equation, like a story, a word problem, a situation, and then represent it with numbers, and then solve it, you might want to practice that over the next couple days before our mastery, because hint, hint, there will probably be a problem like that on the mastery. Luke?
I found out how much bagels cost each.
How much did each bagel cost there?
65 cents.
65 cents. I think that was one of our prices from last week too, so maybe the price stayed the same now.
Models can help you visualize situations and solve some problems.
Okay, I agree.
One type of model that is used for understanding real-world relationships is a bar diagram. A bar diagram is a model that you can use to represent part-to-whole relationships. Consider the following situation. A company has 5 samples to ship to a client. Each sample has the same weight. A box to ship them weighs 8 ounces before it's packed. The total weight of the shipment is 47 ounces. You can make a bar diagram to represent this situation. Let G represent the weight of one sample.
And the box is going to have its own weight. And then we know the total.
Read the problem carefully to build a bar diagram. You know that there are 5 samples and that G represents the weight of one sample.
I could draw them all the same size, and G they're using for grams.
The total weight of the shipment includes the weight of the box, so add that to the diagram.
Sorry, we're using ounces.
This bar diagram represents the total weight.
Then the weight of the box only happens once, and that's going to equal my entire weight.
You can simplify the diagram by writing the 5 G's, which represent the weight of the 5 samples, as 5 times G.
I can just say 5G.
The weight of the box is 8 ounces.
So I now have 5G plus some constant that I know.
The total weight of the package is 47 ounces.
Weighs 8 ounces, so I replace
the bar diagram shows you that the total weight of the shipment equals the weight of the 5 samples plus the weight of the box.
No. I want you to write out what equation would you use, and then how do we solve it? So based off this representation right here, what does that actually tell me? What equation can represent that? We have 5 samples, all with some weight G. We have a box which we know is 8 ounces. Our total weight is 47 ounces. It's a great morning to use cards. So sad.
Thanks to you.
Why? I already did, thank you. I had yogurt this morning. It was wonderful. Brennan just got back. He'll get shuffled back in. Eminal, do you know what equation we can use to represent this situation?
Put 5G plus 8 equals 47.
5G plus 8 equals your total weight of 47. Notice, these are both the same width. Your 5G and your 8, when I model it, 47 takes up the whole thing because the whole 5 samples and box combined weigh 47. So then the first thing that I would do to start solving this, Bella, I would subtract 8 from both sides. Drop it, I have the red already. The right side becomes 39, and that equals 5G. Bela is, oh, you're back there. What would we do now? divide by 5, right? We got to have that by word in there. So we're going to divide by 5 and divide by 5. This gives me that each sample weighs, Luke.
7.8 ounces.
7.8 ounces. Questions on how we figured this out? Let's try another one, except we are now going to draw the diagram for it, or the modeling for it, and solve it. So you and your friend are playing online video games. I know a lot of you do.
I do.
You buy one software package,
Play checkers.
like the game, and 3 months of gameplay. Your friend buys the game, one software package, and 2 months of gameplay. Each software package costs 20 bucks. The total cost is $115. So you guys did this together. Say like you and your friend are at your friend's house, and you ask your parents like, hey, can we have your credit card? Can we buy this? So maybe the software packages here, maybe those are like a downloadable thing or something. So how do we model this? What's our total expense? And then how would we break down and show the rest of it? I'm going to pull the PDF up while you guys try to model this on your paper.
I have a question.
Yeah.
Is your friend included in the total cost?
Yeah, so what your friend bought is all, so you guys bought this stuff together. So I already gave you this little box on your notes, right? So we want to use this box to make our model. So what was everything combined together? What was that total? Cassidy? 115, right? So 115 would span the entire distance there. Then, somebody can give me what I do know or what I don't know. Thomas?
You do know that there are 5 M's. I made it M.
Yeah, so you are combining the months, right? So we have 5 M's. So we could draw them each out individually. There's a month, there's a month, there's a month, there's a month, and there's a month. Each of these labeled with an M. What else did we purchase? Luke? 2 software packages. You bought one and your friend bought one. So software, that was everything. So by the time we list all of that, it should take up the entire space. How do I rewrite this to make my life easier? Not the entire class. Katie, do you know how I can rewrite this, combine some things? Yeah? I'm trying to hear you before I write.
5M
Okay.
plus 2.
Yeah. Yeah, so we could say, for right now, I can still use variables. So 5M plus 2S, and that will equal my whole 115 still, but I'm not worried about writing the equation yet. What else do I know that I can use here?
Each software costs $20.
Each software costs $20, so I can actually say 5M plus 2 times 20. Well, what's 2 times 20? 40. So I can really say 5M plus 40 equals the total 115. And that's why I left space off to the right. I'm really zoomed in right here, but you might on your notes, I'm going to capture this and actually move it to where I think you should write it. I would, if I was you, put it up to the side here. 5M plus 40 equals 115. What's the first thing that I want to do here, Karina?
Subtract 40 by 115 on both sides.
You kind of said that a little weird. but you're right. We subtract by 40 on both sides. Because the first thing you said was we would subtract 40 by 115, which is, you said it backwards. But it's okay. As long as you know what you're doing correctly, just be careful with how you phrase those things. We now get that 5 months of gameplay cost. Luke? $75. And then we can divide. Divide by 5 on both sides. And we get that each month of gameplay is $15. Any questions, comments, or concerns on this process?
This seems just like the same one for like 8 points.
It is. It's the application of the whole chapter. That's why it's the problem-solving lesson. We just take everything we learned and put it together. So reminder, I'm going to remind this a few times, reminder your review for the whole chapter is posted. It's optional but highly suggested so you can prepare for the mastery. I want you guys to try the got it on your own. You can draw a picture if that will help you, or if you think that you're if you think you've got it figured out without drawing a picture, you don't have to draw a picture. I know it says make a bar diagram. You don't have to if you don't want to. You need to be able to think about what it would look like. Because on your homework, you're going to be asked to evaluate some things that are bar grams, and like, or bar graphs, bar diagrams, whatever you want to call it. So think about how would you make this, even if you don't draw the bar diagram on your paper. Then try to solve for the variable value. What costs are variable, what costs are constant, like only happen once and cannot change. I don't know what size it is, but here's a piece of lead if anyone wants it.
I have to have it. I want it. I put it on the thing.
If it's 0.5, it's going to move up the pencil. Oh, yeah, try to push it in the bottom part, yeah, and I don't know if it fits. What is it here that we don't know? What is the variable that we're solving for? Orion? The amount of miles that we drive. So that variable, you know, is going to be attached with the 99 cents per mile. That is what we don't know and what we're trying to solve for. How many miles did we drive in the truck? What things happen once? You know what they are, they happen once, and then they're done with. Layla? How much the moving truck costs? Well, so be careful saying that. I know what you mean, but that's like our flat fee, because this 99 cents per mile is part of how much it costs. That's just on top of the flat fee. But I understand what you were trying to say. What else only happens once, Bella?
The cost of the gas.
Before you take a truck back, when you rent it, U-Haul or Penske or any of those places, you have to fill it up with gas. So even though that's not part of your rental fee that you pay to like Home Depot or U-Haul or wherever, Penske rents out of Home Depot, you have to pay that. That's part of the cost of renting a truck. And my total cost here, because I don't have other colors, I'm just going to underline it. Total cost is $164.67. I always like to write my variable terms first, because just in the solution process, it kind of makes it easier. So, how would I set up my variable term? Eli, do you know what my variable term here should be?
Like 9.99.
Yeah, 0.99m. So if I have 0.99 times the amount of miles, so think about what's my variable term and what's attached to it. Then, what are your constant values that only happen once? So, Cassidy?
0.99m plus 65.32 plus 39.95
Yep. So just to set this up, show both constant amounts. Show that yes, I paid for the gas and I paid for the truck. Then, remember that step before you start solving? We wrote it above our little table there that told us how to solve. Simplify. So Luke, how do I simplify here?
So you add two like terms, which is 65.32 and 39.95.
We add my like terms. Do you already have what it comes out to be?
Yeah, it's $105.27.
Nothing happened to my right side, so it stays the same.
Wait, so you add 65.32 to 39.95?
Yes, because why? Because you asked it. Now you have to.
Well, because that's how much the truck costs, and then how much the gas costs.
But why? What do we call that? Mathematically, I'm allowed to add those because.
You simplify.
Ha! Like terms. So when I see two numbers that have the same variable or lack of variable, they have no variable, they're like terms. That's why we were allowed to combine them and got the 105.27. Then, class, what do I do first to solve?
You
Subtract. We already simplified, so you were right, but we already did that. Now I'm running out of space, so I'm going to move over to the right here. That leaves me with my variable term on the left. What's on the right? Luke?
Okay.
It's 50 something. Probably 59.
59.33.
It's probably going to have a 0 at the end, considering these are both 7. $59.40. Then, class, what do I do to finish this out? Now wait, before you figure this out, I know some of you have already typed it in. What happens to the number on the right side because I'm dividing by 0.99? What's 0.99 very close to? 1. Does dividing by 1 change anything?
No.
No. What happens when I divide by a number less than 1? My value gets bigger. So when I do that division, this is actually going to get higher because I'm dividing by less than 1. Luke, what'd I get?
60 miles.
We traveled 60 miles with the truck. Now, knowing this sort of math is very important. When I went to move our baby grand piano, my wife plays piano, I kind of play piano. We had a baby grand piano in Coshocton. I had reserved a U-Haul truck and was going to have to pay for the mileage and the truck rental. Then Penske called me, and Penske is the big yellow trucks that you see.
Oh, yeah.
And they said, what can we do to steal your business, essentially. They didn't phrase it as steal your business, but that's what they're trying to do. I said, there's no Penske places in Coshocton, and I don't want to pay the mileage to drive to Coshocton because I don't need to take anything to Coshocton. I need to bring something back from Coshocton. There's a U-Haul place in Coshocton. I can pick it up there and just drive it back here, drop it off here. So the guy at Penske said, well, what if I don't charge you mileage? So that would be like taking this 99 cents per mile and just getting rid of it. Completely just not paying that. All I had to do was pay for the truck rental daily. So then, because I had this Penske truck that I rented over here, we went camping. That was one of the things we were doing that week, and that's how I convinced my friends to come help me move this piano, because the piano's really heavy. We just put all our camping stuff in the Penske truck. It was sweet. And then we drove it up on the hill, actually. Like the hill where we camped, we drove the Penske truck up on there.
Mileage?
No, they did not charge me mileage because I said that's how you can have my business. I'm getting U-Haul unless you don't charge me mileage. And they said, okay, we can do that. So I was like, sweet. Luke?
So technically, in this problem, you only would have paid the 105.
Yeah, so in this problem, I would have only paid the constant amount. I paid for the truck and I paid for the gas. I did not pay mileage. So that's how knowing the math and knowing finances and negotiating with people, that's how you can save yourself lots of money. I've done that a couple times now. So temperatures. What 3, notice I said 3, scales do we use to talk about temperature?
Oh, I know.
I'll come to you for the third probably. Luke?
I know it's Fahrenheit and Celsius.
Fahrenheit, Celsius.
Kelvin.
Kelvin. Kelvin is exactly like Celsius.
Absolute.
It just starts.
Scale. It starts at absolute 0.
Do you know how much further it is below 0 Celsius?
Negative 294.
Ooh, you're close.
I know it's
So here's 0 degrees Celsius, which is freezing, right? This is outside when it's 32 degrees Fahrenheit. That's 0 degrees Celsius. In the Kelvin scale, that's 273 degrees Kelvin, which means 0 Kelvin.
Use Kelvin cold.
0 Kelvin.
freezing point.
No,
Do you know what happens at 0 Kelvin?
There is no particle movement. It doesn't radiate any wavelengths.
The biggest thing is the first thing you said. Particles stop moving.
And also, the hottest something can get is called a Kugelblitz.
A Kugelblitz?
Yeah, and it becomes a black hole.
Ah, okay. Very cool.
That's like
Like millions of Kelvin, probably?
No, not millions. It actually gets into exakelvins. Or no, yeah.
Wow, that's insane.
Yeah, and
So, we don't use Kelvin a lot, but when we do, it's an easy conversion. All you do is take Celsius and subtract 273, or sorry, add 273. So if you know the Celsius, you can immediately find Kelvin. All you have to do is simple addition. Converting between Celsius and Fahrenheit, not as easy. So here's the formula. Hey, have a good attitude on a Monday. Here's the formula for finding Celsius if we have Kelvin, or sorry, if we have Fahrenheit. We want to derive the formula for what is Fahrenheit when we know Celsius. So essentially, I want to get F by itself. So when I look at this formula, and my goal is to get F by itself, I'm going to try to give myself some space. So I have C equals 5/9 times F minus 32. So now I'm going to make my green what I'm doing to both sides. What should I do first here? This is kind of tricky. Remember, we're working the order of operations in the reverse order. I got the same two hands that I have up pretty much all of class. Franny?
add the 32 on both sides.
You are falling in the trap. If we were working the order of operations down, parentheses happens first, right? But since we're working them up, parentheses will happen last. So, Karina?
I don't know. I think, would you do the reciprocal?
Because we have a fraction outside, we do the reciprocal to get rid of the fraction. So we multiply both sides by 9/5. We multiply by 9/5 because here the 5s will cancel, the 9s will cancel. I get left with just F minus 32. So guys, you want to show this work on your paper because you're going to have a problem like this on your homework. That leaves me with 9/5 C equals F minus 32. Because that multiplication of the fraction is gone, I can get rid of my parentheses. So now, what do I do to finish getting the F by itself? Bella? Now is when I add the 32 to both sides. And we get that F is equal to 9/5 times whatever my C value is plus 32. And this is because this conversion equation is complicated because they use a different scale. 1 degree of Fahrenheit is not 1 degree of Celsius. What is the distance between freezing and boiling? For Celsius. At what temperature does water boil Celsius? Anyone? 100. At what temperature, this is when people don't know it, at what temperature do things boil Fahrenheit?
212.
Isaiah?
Dang it.
212.
212. I always remember it as 212, just like it's just right there. So notice the distance between them. In Celsius, this is 100 degrees. In Fahrenheit, this is like 100, oh, we could do the subtraction, 80? I think it's 180, because you take the 12 away and then you still have 20 there. So guys, notice the scales are not the same. 1 degree is not 1 degree. Yeah. So we could have started by distributing, but last week on Friday we looked at the other method that we can use to solve these that is a little bit easier and a little bit quicker. So you could have distributed first, but 5/9 times 32 is a little messy. So that's why I don't like that. I can get rid of the 5/9 by just multiplying by its reciprocal. Thomas?
So isn't the only, I know there's like one more, but I don't know it, but is it like negative 40 degrees Celsius and negative 40 degrees Fahrenheit?
Yeah, there are 2 places where they are the same.
Wait, what's the other place?
You can calculate it, honestly. If you set Celsius equal to Fahrenheit and then play with the numbers until you can find out when will C equal F. But we're not going to we don't have enough time because we talked about the lottery and stuff. So we got to talk about Magellan. Magellan is a spacecraft. It was launched in 1999, probably before most of you were alive. I was 10. During its 463-day flight to Venus, it traveled about 806 million miles. That's a lot. Solve the distance, our dirt formula, by how fast it was traveling. So we know how far it went. We know the distance. We know the time, how long it traveled. So here's the thing. When we get our rate, it will be in miles per day. Unless we convert day to hours, but we don't need to. We can get miles per day. So set up your dirt formula, D equals RT, and then we're going to fill in for it. And I'm actually probably going to bump over to the right a little bit. So that's captured up on the TV so you can still see it. I have my dirt formula. Distance equals rate times time. Our distance, 806, and I'm going to label it MIL. So I just remember that's 806 million. Just so I don't write all those zeros, I'm just going to put MIL for million. You could put the zeros if you want. You'd have to put 6 more zeros on there. My rate, I don't know. And my time was 463 days, right?
Yeah. Yep.
How do I solve for the rate? Crystal? How do I get this R by itself? Brian?
You divide 106 million by 460.
Yeah, because this is being multiplied, we have to divide by that number, and we have to do it on both sides. So that's going to give me my rate is equal to, it's going to be slightly less than 2. What do you get? 806 divided by 463. Don't worry about all the zeros. 806 divided by 463.
1740820.
Wait, so you got like 1.74.
I did the actual division with the million, and it's 1740820.
So here, 174.
Point.
So this is 1,740,820 miles per day. Now, given that's in a day, okay, well then obviously you can drive further in a day than you can per hour. So how do we take this from per day to per hour?
Multiply by, you divide it.
Bella? Now this is 1 day. We know how far we traveled in 1 day. Let's assume we went the same speed the whole time. Ask yourself, am I going to go more miles in an hour or less miles in an hour? Less. So we take this and we can divide it by the hours in a day.
I know the answer. Okay, it's 72534. That's like 72,000.
So they were going 72,000 miles per hour.
Can you die to that speed?
Yes, you could die at that speed. Like,
What happened if you're like
now I forget if Magellan was manned or unmanned. You'd have to look it up. Hey guys, I got like 2 minutes left. They're releasing early. Don't know why, but I actually have until 49 according to our schedule. So I have at least 3 minutes left. Rye, can you manage those people out in the hall? So we've now solved our rate just as given. Yeah, and then rate miles per hour. We got both. So let's solve this for time. An orca swims 704 feet per minute. Let's skip right to B because we're running out of time.
Okay.
How far will it, or how long will it take it? Now what this was trying to do is solve the dirt formula for T. If I want to get the T by itself, I just get rid of the R. I can rewrite this as time will equal distance divided by rate. We can use this formula to make my life easier. If I'm looking for time, it's your distance divided by your rate. So down here, my time will equal, well, my distance is 26,400 feet divided by the rate that they swim, 704 feet per minute. Sorry, what do you get? 37.5? And that will be minutes since we started with our rate in minutes. You should have no issues doing your homework. Please come to class tomorrow with questions about the homework. We'll either play the review game tomorrow or we'll play it Thursday. I have yet to decide. We'll probably just take this mastery on Friday. So plan on this mastery being on Friday. Huh?